All right, multiple events part 2 here, kind of finishing up. We're doing the OR probabilities. And as you can see, when you do an OR, you want to add them individually and then subtract any overlap if there is any. So for the second part B here, using our tray of shapes, I want to do the probability that it's orange plus the probability that it's a circle minus the overlap, which would be the probability it's orange and a circle. Okay, so looking at our shapes and kind of marking here, probability that they're orange. See if I can do this. So orange ones are just 2 out of 9 total. Okay, plus the circles, which are 1, 2, 3, 4, and 5. That's 5 out of 9. But then what happens is this orange circle right here got counted twice, so we have to subtract it off. So there's one that got counted twice, so subtract that, and we get a chance of 6 out of 9, or 2/3 chance that it is a orange one or a circle one if we randomly ate one of the colored shapes off this plate. Don't ask why you're eating colored shapes. Nobody knows, but that's what this question's about. Okay, so another one from like the world of cards and poker or something. So we want to get a face card or a heart here. Okay, so see if you can make sense of this OR probability. Pause the video and give it a shot. Okay, so I'm going to do the probability of a face card plus the probability of a heart, but then I have to minus the overlap, which is probability it's a heart and a face card. And because there are some heart face cards, so they're going to get counted twice. So you have to subtract that off. So to me, this is a really good thing to look at visually. So here's all my hearts, right? I have a hard time drawing it. That is 13 out of the 56. And that thing is really, sorry, 52. It's really messing up here. That's 13. Okay, and then the face cards are all of these, right? So that's 12 out of the 52. Okay, and then I'm going to minus the 3 that got counted twice. These 3 heart face cards got counted twice, so I'm going to subtract that off. So that's 3 out of 52. So my chance of getting a heart or a face card is 25 minus 3, so I have 22 out of 52 chance. Okay, and again, you could, write it as a decimal or reduce it. I guess it'd be 11/26, but the main idea is that you know how to come up with that OR probability. Okay, so just a super straightforward one here. This I don't like this because there's no context, but just do the formula quick. So you're going to add them together, and then you're going to minus the overlap, which is the and. So that would be Q and R. Okay, so Q is straightforward, it's just 1/4. R is 2/5, and then the and I would get by multiplying them together. So here's the chance they happen together. Oh, you know what? You know what? You know what the chances are they happen together? That is 0, right? Because it says they're mutually exclusive, so there is no overlap, right? They don't ever happen together. So I should have been more careful when I was reading that. Okay, so this should be then, I need a common denominator. Maybe I'd use 20. So 1/4 is 5/20. So if we take this times 5, okay, and then take this one times 4 on top and bottom, so that would be 8/20. So altogether, that is 13/20 chance that a Q or R happen. Okay, so I normally have them do this on Schoology, but I'm not going to do that here. So I just want you to do this. This is a really good test of everything we learned because there's a ton of vocab and and or probabilities in this lesson. So you're going to go running every other day, so 50% chance, and the moon is full 1 out of every 30 days, approximately. So are they dependent or independent events? Are they mutually exclusive? And then the and probability and the or probability. So pause the video, try these. This will be a really good test to see if you got this information. Okay, so first one is independent. I mean, I'm assuming that, I guess, but our running is not depend at all on if it's a full moon or not, and vice versa. Are they mutually exclusive? No, they can happen together. It could be both a full moon and you go running. For the and probability, letter C, you just have to multiply. So I go running 1 out of every 2 days, and then it's a full moon 1 out of every 30. So the chances it's both is 1 out of every 60. Okay, and then the or again, I've got to add them together, but minus the overlap. Okay, so 1 out of every 2 days I run, and 1 out of 30. Sorry, my thing is glitched. So 1 out of 30 is a full moon, and then there would be 1 out of 60 days that was both running and full moon, so it essentially got counted twice, so we'd overlap it. Or sorry, we'd minus off that overlap because they got counted twice. So I'd make common denominators here. So 1/2 is like 30 out of 60. 1/30th is 2 out of 60, and then I can keep it as 1/60th. So now it would be 32 over 60 minus 1. So we have 31 out of 60 days that are either running days or full moon days. Okay, and I attempted to do this visually. It's kind of a poor visual because this isn't a total of 60 days, but you can see this is roughly 1 month, and then you have a full moon that's on a non-running day. But then the next month, right, we go every other, and then this time the full moon fell on the running day. Okay, so this would be like the 1/60th where they overlapped. Okay, and all total, right, if we count all these up, there would be 31 out of 60 that were either running or full moon, right? So again, you add the 1/2 plus the 1/30th minus this day, because this day got counted in both of these fractions. So you minus that 1/60th, and that's how we get to this. And again, this is kind of a poor visual because this isn't technically 60 days total, but hopefully you get the idea that sometimes they're going to overlap. They'll fall on the same day. All right. That is it. Thanks for watching.